Okay, so welcome back. So in this video we are going to write our first smart contract. So first of all we are going to create our npm uh, project with npm init. So first you have to install node.js. So I hope that you have already installed node.js in your system, or I'm using Windows, so you can just go to node.js website and download it for Windows, or if you want to install it on Linux or any other operating system. So this is the package name, so I'm just pressing enter for everything. So okay, so this package.json is installed. So first of all we need different packages like npm install Hardhat and ethers 5.7.1. so I'm using this version of ethers because the current version, it has some problems when I'm running the code, so that's why I'm using a previous stable version so that we don't see any error in our code. So let's just hit enter. In the meantime I'm going to create an env file, and in the meantime it's being installed. Okay, so let's just wait. Okay, so this is installed. So now we need to create a Hardhat project. So for this we are going to write npx Hardhat. We are going to create a JavaScript project. The TypeScript we will do in the future, but for the time being we are doing JavaScript. This is the root directory. Yes, we want to add git ignore. So now our Hardhat project is initialized. We have these contracts, the script. So let's just delete this contract. We will create our own, and this deploy.js, let's just delete it. And in the Hardhat config we have this package which we need to install. So what we can do is npm install this and .env, because we have created an environment variable file and we need this package to import it in the node.js project. So we are going to install it. It's being installed. So in the meantime let's write our first smart contract. Let's call it task to do dot solve. Okay, so first of all what you have to do is you have to write spdx dash license dash identifier gpl dash 3.0. this is just like you need to write it like every time. So pragma solidity, and we want to make it for the version 0.8.0. like this sign indicates that this smart contract is valid for all the functions, no sorry, all the compiler versions that come after 0.80. and then we are going to write our contract name, contract task to do, and okay, so now our, so okay, this is, so spdx license identifier. Okay, so we are just going to ignore it right now. So let's just create a task to do function. So in the smart contract we are actually creating a to do function which actually takes the input from the user for the task the user has to done. Normally you must have seen the full stack tutorials in which this data is stored on MongoDB or any other database, but right now we are going to store this data in the blockchain. So we have, let's say, a task, I want to buy eggs, or I want to clean my room, or I want to do something. We are going to write it in the smart contract. We are stored it in the blockchain network, and we have our like two options: either this task is finished or either this task is pending. So first of all we are going to write enum task status, either it's pending or finished. So it means that we have this enum that we are going to assign this task status to all the tasks, either it's pending or finished, and we are going to change it through the smart contract functions. So, and let's define address owner. The owner of the smart contract will be the one who deployed. And now we are going to define a struct and we name it task. Now this struct actually define the description of the task we are going to write in the blockchain, and task status. So now this struct is going to tell us what is the name of the task, and either it's finished or not. And then obviously there are many tasks, so it's not just one task. So we are going to create an array of tasks, and let's keep it private, or maybe let's keep it public, and tasks. We are going to name this array tasks, and then we are going to make our constructor where we are going to, let's say that owner is equals to message dot sender. Okay, and let's create a modifier only owner. We need to define a require statement in which message dot sender is equals to owner, otherwise it gives the error of not owner. And the syntax is we have to put underscore. So what this modifier does, the modifier makes it like when we put this modifier in the function, it means that only the owner of the contract can run that function. So let's just write our first function add task. And now in the task we have the description string. So what we're gonna do is string memory underscore disk, and this function will be public, and let's put only owner. So it means that only owner of this smart contract can run the function. And this memory here, this memory depicts that the string, this underscore description, it is going to be stored temporarily, and as the function is run, it will just disappear from the memory. So this is just the syntax to mention some string as an input in the function. So what we're gonna do is we gonna do tasks dot push, and this is our struct task, and what we're gonna do is disk and task status dot pending. So now we have two status like pending and finished, so we are going to put pending here. Okay, now we are going to write a function where we can mark this function as, okay, so let's just give some spaces. Okay, function mark as finished. So let's say uint 256. Let's say ID, we are going to give the ID of, because this task, it is storing it in the array. So at the, let's say at the index 0, the first task is being stored in the index 1, the second task is being stored. So we are going to give index, and then we are going to make it like public, and again only owner, so that only owner can run this function. And what we can do is, first of all, we need to see that if the task exists or not. So we are going to make require the ID should be less than, sorry, it should be less than, we have task array dot length. So it should be less than task array, otherwise we are going to say that no task has been written or has been mentioned. And then the second thing what we're gonna do is we are going to make tasks of id dot status is equals to task status dot finished. So in this line of code what we are doing is first of all we are checking if the task length or if the task is present in this array. If a task is present, then we are going to change the status of that specific task as finished, because it's pending when we are adding the task, so we can mark it as finished. So now we can create another function where we can actually get the tasks. So we can write a function get task count, and we can say public view return. Since this function is only like returning something, so we are going to write view and returns its uint 256, like it's going to return an integer. So what we are gonna do is return task dot length. And let's say we want to get all the functions, because we are going to write an API in the backend where we are going to add the task, where we are going to mark the task as finished. We are going to get all the tasks. So function get all tasks, and we are going to write, sorry, so we have this public view returns. So we are going to return an array and memory. We are not going to store this array, so we are just storing it in the memory, so it disappears after our function is run. So what we can do is simply return tasks. And finally, let's say we want to return just one task. So what we're gonna do is we are just going to create a function get one task. Sorry, we can just say like get task, and we want to mention what kind of task or what is the ID. So we can say like, so instead here to, okay, so this ID and public view returns string memory and task status. So it's going to return this like the struct, the string description and task. So it's going to return string memory. So first of all we need to actually see the same thing, if a task is present or not. So we are going to copy the same thing, the ID, and in the second thing what we are gonna do is we are going to return we have this tasks array, and we are going to take ID dot disk. What is the name here? Disk. And we are going to copy this and we are going to paste this at task status. Okay, task status. Okay, sorry, so it's not task status, it's status. So sorry for the typo. Okay, so our smart contract is ready now. So what we can do is now in the environment variable, first of all we need to like API underscore URL, and then we are going to give our private key and then contract address. So first of all we need we need to select the type of blockchain which we want to use and deploy our smart contract. Then we need a private key, because when we are going to send a transaction to the blockchain network from backend, we need private key. So we are going to put our private key here, and then in the Hardhat config file we are going to actually give the blockchain address or the type of blockchain or all the like blockchain characteristics here. So like we will just like go here, and in my GitHub repo, if I go to this Hardhat config, I have it here, so I can just simply go copy and paste it. So this .env is actually importing the environment variables here. We have this API URL and private key, and so we are using Energy Web Chain, which is an Ethereum based blockchain. So this URL is API URL. So if we can actually see if we have this environment variable here, yeah, we have env here. So we can just simply copy and paste this RPC URL. So what is this RPC URL? When you want to interact with the blockchain network, you basically need an endpoint to that blockchain, and this API URL is actually the endpoint. So whenever you are sending or you want to retrieve some data from blockchain, you are going to post your data here, and then it can be written on the blockchain, or you can retrieve it from the blockchain. For the private key, we can actually go and download our install MetaMask, because we need private key, and let's say add. Okay, let's say create new wallet. I agree. Let's write 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. You can just like create your own wallet, and I mean it's not that, so like remind me later. I understand. Okay, got it. Next, done. So like I have this network here, so we have Ethereum mainnet here. So let's say we want to add Volta testnet configuration. So like we can go here, and we can actually get Volta's okay, where is, I think, yeah, it's here. Where I can see the custom RPC. Okay, it's here. Yeah, it's here. So let's like try putting the MetaMask. Okay, let's setting networks, add network. So let's say we want to put our add a network manually. Network name is Volta. The RPC URL is the same URL we put before in the environment file. The chain ID is 73799. So basically this is just like the home address. You are giving everything. The currency is VT, and the block explorer is Volta. So we have saved it, and let's copy this address and let's go to Volta faucet. We can get some coins for free to test it. And okay, bicycles, bicycle. Okay, so we can request our 1 Volta token. So we are going to see this, and let's say we can, if we can, cars. Okay, where are cars? I can't see any. Here. Yeah, okay, done. So we can request 1 Volta token again, and and if we can see if we got our tokens, okay, we have this extension. So you see we can have 2 Volta, we have 2 Volta tokens now. So now I wanted the private key, so I will just go here, account detail, export private key, 1 2 3 4 5 6 7 8, confirm. So this is our private key. So we are simply going here and we are putting the private key here. So now we have our network ready, and we have this environment file, and we also have our smart contract ready. So what we can do is we can have np, so in order to compile the smart contract we can have npx hardhat compile. Okay, so one contract has been compiled successfully. Now in order to upload this contract on the blockchain network, we have to write this deploy.js. so I'm just like going to my GitHub, and I'm going to like copy this code. Now this is a hard-coded code, so just like copy and paste it, and in order to like do it in a right way, you just need to copy and paste the contract address, and let's like do this, let's do this, and this final line is going to like upload the smart contract. So let's see like what type of command we can use to upload. So here we can see npx hardhat run, so we are just going to copy, instead of localhost our network name is Volta, so we are just going to run this, and let's see if our smart contract is uploaded. So okay, so this has been uploaded, so we are going to go to environment variable, and we are going to copy and paste this smart contract. So now the first part is done. We can go and see this smart contract on like Volta Explorer. We can just go here and we can see, okay, you see like 19 seconds ago we have deployed our first smart contract. So this is the first smart contract we have deployed, and now in the next step we are going to create a backend which actually communicates with this smart contract on the blockchain network, and then after that we are going to create a front end where the front end is either like going to send the request to the blockchain directly through the JavaScript, or it is going to send the request to the backend, and then the backend is going to communicate with the smart contract on the blockchain network. So that's it for this video. In the next video we are going to write our backend server which is going to communicate with the smart contract. So thank you very much.